Hey ManCavians, this is Bob from the Bob's N-Scale ManCave, and today I am making a custom-made bracket for my electronic servos for switch machines and other animation that you may want to do on your layout. These servos, usually commonly used in model helicopters, model airplanes, those are remote control stuff, and remote control cars, but we also use them in model railroading, and they're becoming very popular with modelers because they can be electronically controlled, and they're slow, and they can be adjusted to whatever you need it to be used for. I needed a custom bracket because I'm mounting all my servos on top of the layout instead of from underneath. There's already a bracket for these if you go through Tam Valley and get their servo kits, which I'm also running these servos with Tam Valley products, but I didn't get the mount because I'm not going to mount it to the bottom, and it didn't really work out very well to mount that on top of the layout. I wanted something low profile so it didn't really stand out, and I could cover it up with buildings and stuff like that if I need to. I'm going to show you how to make it, and we'll go from there. Let's get started. Okay, first thing you need to do is get out your 1/2 inch wide channel, aluminum channel that you picked up, and cut 2 pieces that are 1.25 inches long using your hacksaw. Kind of go slow, make sure it's nice and smooth. Also, when you're done cutting those pieces, get out a metal file, like one of these, and get all the burrs off of the edges, around all the cut edges, and make sure they're nice and smooth so you're not snagging your fingers on them, cutting your fingers open and catching your clothes and everything else. It's kind of painful. Once you have those pieces cut, the first piece, which is going to be the bottom, you're going to drill 2 5/64 inch holes into the bottom of this bracket. So once you do that, I took a countersink bit, and on the inside of the channel, on one end of it, I countersunk the hole so that a wood screw can sit down inside of it. And this will be a number 6 1/2 inch wood screw. And the other piece of metal, I cut 2 slots, kind of make a little U shape there. You cut it down to the point where the wires are no longer pinched by the top. So as you're sitting this down here, this piece here will slide right over the top of the wires and sit on top of the servo just like that. Okay, so you're cutting the channel out, and that's the easiest way to do it, using your hacksaw. My idea might be to modify this bracket by using a drill to drill a big enough hole down here at the bottom where the wire is at, and feeding the wire up through this area, leaving the back end of it nice and solid, so I can drill a real hole through there and make it a lot sturdier later on. But since this is my prototype, live and let learn, you know what I mean? So the biggest thing is make sure your wires are not crushed. Once your pieces are cut, you're going to want to make a small little spacer that will fit inside the 2 pieces of channel to separate it and keep it nice and even. The biggest thing is this piece should be at least the height of the servo as it sits in there. And this one just happens to be a little bit taller, and that's fine, just as long as it's not extremely tall. Once you have all these pieces cut, get out a piece of cork or your 1/8 inch MDF hardboard, cut a strip that'll fit underneath your channel mount, and you're basically ready to go. So let's go put this thing together. Don't crush your cork, just put it down so it's snug. Because the more you crush it, the less space you'll have on the edge here. The mount in. And there you go, just like that. Pretty easy. Now I just have to put this on the actual layout and I'll be ready to go. If you don't have this spacer in here, the two halves don't line up. They slide around and don't give you any kind of compression on the mount, on the servo. So it won't stay nice and tight in there. This is not going to move out very easily. It could, but it's not going to move, and more than secure. Okay, I have modded my track and my switch. This is a Pico switch, and Pico switches have a spring-loaded switch in here to keep things nice and stiff when they move back and forth. I've removed that spring so these points are nice and loose. I'm going to mount the servo, but first I got to know where I want to mount it to. So I'm going to kind of line it up so that the movement of this arm that I'm going to put on here is nice and perpendicular with the movement of the switch. Make a line. Where it's going to kind of travel. I want to keep the machine far enough away from the switch that things don't bang into it when they go by. Probably a good inch is a good idea. I'm probably going to move this a little bit closer to the edge of the wall, because the wall is right here. So this will be the inside of the room, of course. Mount this. Take my cork. glue down this cork if you want to. Now you may already have cork glued down in this area. But you really don't have to glue it down since you're going to be screwing screws right through it. It's nice and flat. Servo's all the way in, so I can't go any farther back that way. And it's tight that I ain't gonna move in and out. Now I just gotta hook up a piano wire between there and the switch. Piano wire is really hard to cut through with a diagonal cutters, so be careful when you do it. That little piece, hold on to both ends, they'll separate real fast. There's a hole right next to these little nubs on the picos that I can shove this wire through, and then I can wrap that right up through the top. I'll go from underneath and poke up through the top and bend it over a little bit so it doesn't fall back out. And the other end I'll put a little spring loop. So you just basically make a U shape in the wire so that it puts a little spring tension to it. So when this arm moves over, it pushes into that spring area, and the spring will basically keep all the tension on here without overdriving the servo. Okay, just take your needle nose and put it right there on the edge. Give that a 90-degree turn. Just enough to stick up through there. Slide it underneath. Just bend it up, and now it pops through the top. So now, I didn't have to cut any foam from underneath there. The foam will actually keep the pin in place. And the switch will move back and forth nice and easily, if you can see that. So it's going to sit like this. And I'm just going to make a loop to go this way. Take it out maybe 3/4 of an inch. A loop like this. The switch will sit up like that. And this is now it's a little spring action there. Okay. Not the same spot over here, because I need to take and keep a straight line for the travel. I need to keep a straight line through the travel, because the switch is over here, the servo is over here. I need to keep in line with this, so I need to make a bend right on this edge. There. So there you go. So now I got to get it into this loop, into the arm. So I'm going to have to bend it in there and make it fit. Size it all up here. So now it's in the hole. And just need to make this arm go up into the lower hole here. So I'm bending that up. I'm going to take the arm off the servo. Orientate the holes where I need it. So that's going to mount right in there. Now I'm going to have to bend this up and into one of the other holes to kind of keep it from sliding in and out and moving around too much. So I'm going to make this arm nice and tight. I've decided to just bend this in a 90-degree angle so it just fits up in here, so it will give a nice free movement without any binding. So I'm just going to mount it in here. Squeeze it on there. Okay, the kit comes with a bag of screws and various arms, and there's two screws in there for mounting the servo to some wood or whatever. But then there's this little tiny screw here that mounts the arm to the servo. Don't lose this, or it's going to be a little tough keeping your arm on your servo. So there you go. I have mounted this servo. It's got a little spring action in there, and when I get all the electronics hooked up to here and adjust how this is going to move, it'll also adjust the tension on here, and everything should be working just fine and peachy. Okay, we're going to adjust this servo to work with this switch using the Tam Valley Switchwright controller, a Tower Pro SG90 servo, and Tam Valley's recommended 5-volt power supply. It's a filtered switching mode power supply. Won't give you a lot of spurious frequencies on your power, so you won't have a lot of chattering or wearing out of your electronics. So they highly recommend that. So basically, I have the switch hooked up, and I put the wire in here. I had put it down in the bottom hole originally, and that was probably not the correct position to put it in, since I have it so close here to the switch, and the spring is not loose enough to really allow it to move so much. I moved the hole up to a higher position so it doesn't throw back and forth as much, because then it pushes too much and the servo will release and center itself, and so it won't really work right. It'll look like there's an error, and there really is an error. So you plug in your power supply, which I'm going to do right here. You get your jeweler's screwdriver, because you're going to need a small head, flathead screwdriver to screw in these tap screws on the board. So get two wires, positive and negative color wire. You get one of these plugs. You can also get them from Tam Valley or some other source. Wire the positive in on one side, the negative on the other side, and the same goes on the other end. They are marked on the connectors. Once you do that, according to the instructions, take one of the jumpers, and on the side here where the power is, the first set of jumpers, put that jumper on there, and that will center the servo in the center of its travel. Also, the options for speed are the first two jumpers. If you put one jumper on there, it's medium speed. If you put both jumpers on here, it'll be as the fastest speed. If there's no jumpers on there, it'll be the slowest speed. So I'm not going to put any jumpers on those. The next one over is the throw. Currently the throw is as far as it will go. If I put a jumper on that, it'll go half the distance. So I'm going to put a jumper on that middle one, so I only want it to go half the distance. The next jumper over is called on, which leaves power applied to the servo once at all the time. Once it moves to its position, it usually turns off. You probably don't want to leave it on all the time, but in some cases you may need to, but not in this application. I wouldn't do that. This jumper over here is for your servo. In this case, the instructions say the S on this side is for where the white wire goes. Well, I really don't have a white wire. I've got an orange, red, and brown. So it's a 50-50 shot. So I've already done this once before, so I know which way it's supposed to go. And the orange is going over to the S side, or the orange is considered white. Then you also have a control button system with some LEDs, and that will give you a manual way of switching your servo. The white wire here goes to the S side, and like that. Now there's other configurations here for a powered frog. You get a DCC signal in here, which this is an addressable machine, so you can run it from your DCC controller and switch your switches. But this is a manual way to do it, so we're just going to use this to set up the switch. Okay, I'm going to power up the controller, and you saw the servo move, and it centered itself. Okay, so I'm going to take this off. You probably should have taken this off first before you center it. So now that it's centered, I want to take and put my switch in the middle of its throw pattern. So I take my throw arm and hold down the switch where I want it and put the arm onto the servo. Press it on there, and that should be good. I go and I take this jumper off of the control board, and the servo moves over to one of the positions. And as you can see, there's a red and a green LED. You may not be able to see that very well in this light there. But if I press the button, it'll flash, and the servo moves to the other side, and green moves over to this side. If I press it again, switch moves the other side, red's now on this side, green's on this side. So you can have this indication on your fascia or mount this on your control board. You can get extension cables. This is only like a 1 foot cable, but you can get some extensions or splice in some extra wire to increase your length all the way to your control board, which is probably what I'm going to end up doing. So play with it a few times, see how it works, see if you have enough tension, and I can't really push this switch back, so I got pretty good tension pulling it to one side. Going the other direction, it's pretty tight, and I can't move it back. So if you've got a good switch and good points, you're never going to have any derailments using one of these machines. Now what you could do is take this board, and there's a couple mounting screws in the package, and you mount it to the board somewhere, underneath the board, somewhere convenient where you can have all your electronics mounted, hidden away from view. You can also hook up a Y cable to the end of the servo area, so you hook two servos into the same control unit. So let's say you have a crossover, you want both switches to switch at the same time, and you can wire that up so that it will do that. You just kind of make sure you have your orientation of your switch machine on the correct side, and you can flip it around the other side so that it moves that way. So a little planning involved with that, but you know how to figure that out. You guys are smart. All ManCavians are smart. Well, there you go, ManCavians. I showed you how I made my own mount for a servo for activating a switch and hooking that to my track and the switch on the track. Also hooking up a Switchwright machine and programming it for moving that servo, and all those little things that you need to do before you actually start using it on your railroad. There's more advanced options like hooking it up to your DCC bus line, and also that enables you to program this Switchwright machine to a specific address, and you can then remotely switch your switches. Or you can run long cable to your control panel, have a remote toggle switch like I showed you, and do it that way. But if you like what you saw here today, ManCavians, subscribe right up here. Also, click my links down below to like my Facebook page and my Google Plus page, and follow me on Twitter. And as always, ManCavians, happy model railroading. Stay off the tracks. Bye.